total experience of 11 years, and her area of specialization is network security and machine learning. So now I would like to invite today's speaker, Tanvi ma'am.
Thank you, ma'am.
Yes, ma'am, you can start now.
Yeah, okay. So good morning, all of you. So the topic which I'm going to discuss today is the introduction to machine learning. So first of all, before starting with the concept of machine learning, I would like to discuss that what we are doing in the traditional programming. So traditional programming means where we are just performing a concept of like input, process, and output. That means we are having just a set of predefined instructions and we are just executing those instructions. Ma'am, am I audible? Neeru, ma'am?
Yes, ma'am, audible.
Yeah, okay. So what concept we are following over here with the traditional programming is that we are performing an static structure. Okay, so where we are having a predefined instructions. Next, now as compared to this classic machines, or another name for classic machine is as non-adaptive machines. Okay, and these non-adaptive machines, we are having an what we can say a static structure. Now as compared to this, we are having a machine learning concept which works on the concept of adaptive machines. Adaptive machines which are dynamic in nature. So now in this machine learning, we are having a term that is learning. Now what do you understand by this term learning concept, which follows and three important terms. The three important terms over here are like E, that is the experience, P is the performance, and T, which stands for the task. So these are the three important terms that comes under the learning concept. And learning means what in generally? That is change in behavior. That means continuously we are having change in the environment and we are performing our concepts with that particular environment. So in machine learning, so or a basic or an simple example related to this three terms, that is experience, the task, and the performance. Depending on this, a very basic and simple example is like we all are using Amazon apps. Now what if you want to purchase, if you want to search any of the product, we are opening that respective app, we are giving the name of that particular product which we want to purchase, or if we want to just search for any of the product. We are searching that particular product, then we are getting a list of products. So one by one, we are looking at it, whichever the product we want to purchase, we are placing it into the cart. Okay. Now you are closing that app. Now after some days or say some months or years, again you are opening that respective app, your Amazon app. Like you can see that the products that you have searched previously, which is being, those same products are being highlighted to you. That there are some say keywords you can see in the Amazon or in any of the apps, like related products is there, similar products is there, or recommended products are there. So what do you mean by this particular terms is that whichever the products which were you were interested, all those products are being shown to you or it is being highlighted to you. And how this particular concept is being followed, that is with the help of the machine learning. Okay, so previous products which is being shown, which means that it is the past experience. Okay, so machine learning, this particular concept, it tries to grasp or it tries to follow the past experiences that the machine, the model or the app which it has been performed. And that is why the basic definition of machine learning is it is a field of study that gives computers the ability to learn without being explicitly programmed. Okay, So we are not performing any program over here, but whatever the experiences that we are having, according to that experiences, we are getting an respective outputs. Okay. And similarly, the next is what? Machine learning is nothing but it is a subset of artificial intelligence. Now, first of all, now what is artificial intelligence? Now, it is just a development of programs that we can say which behaves or acts same as that of humans. Okay. And for performing this respective task, we are having some set of algorithms which are being developed with the help of machine learning. And that is why machine learning is said that it is a subset of artificial intelligence. And this machine learning concept, it was being developed in the 1960s. Okay. Next is what? Here that we can see for building any of the model or a machine, the model, it has to follow some n number of steps, or in other words, what we can say, that is the phases that we have to perform. So in this phase, in this particular life cycle, the first phase that we are having is gathering data. Obviously, if you want to generate, if you want to create any of the model, without data, we cannot perform anything. So gathering data, so here in this first phase, we are going to collect the data from n number of sources. So it can be an primary source, it can be secondary sources, means like through internet, we can have through online, we can get some of the data. Through some textbooks or reference books, we can have some data. So in depending on the project or depending on the problem statement, we are going to collect the data. After collecting the data, the next phase is data preparation. So what task we are going to perform in the data preparation is that after gathering the data, we need to place that data in some suitable environment, or in other words, what we can say, we are going to analyze that data, or we are going to see that whether the data which we have, whether it is related to the problem statement or no. Okay, that is the second phase, that is data preparation. Third phase, which we are having over here, that is data wrangling. Data wrangling, or in other terms, we can also call this data wrangling as in data pre-processing. So data pre-processing, what is going to happen over here? In the third phase, this is the most important phase of the life cycle, because depending on this particular third phase, we are going to check the performance of the model, whichever the model is going to be generated. So in this, what we are going to do in the data wrangling concept in this phase, we are going to remove all the invalid data, then the duplicate data, or the data which is missing, we can replace that data as well with a meaningful insight. Okay, so in this data wrangling, we are going to remove unwanted data, and the data which we are going to pass it to the fourth phase, which will be an genuine data. Meaningful insights will be there after this third phase. Then that genuine data will be passed on to the fourth phase, that is analyze the data. So analyze the data means in this case, now as we are studying the concept of machine learning, we are going to have n number of algorithms depending on the concept that we are going to discuss in the next slides. That is, we are having the concept of, say, classification, regression, clustering, association. So each and every concept is having some different n number of algorithms. So whichever the algorithm we are going to select, that will be analyzed, or that particular algorithm will be applied to the fourth phase for that respective data depending on the problem statement. After analyzing the model, or after analyzing the algorithm which we are going to select, then it will be passed on to the fifth phase, and that is the train model. So as from the third phase, from the data wrangling phase, we are having an meaningful data. Now that meaningful data in the fifth phase, that is the train model, in the fifth phase, that data will be utilized. Now, in the machine learning, okay, so what we were discussing about the fifth phase. So training the model means where we are creating the model, and during the creation of that model, we are using the 80% of data. Then next phase is the sixth phase. That is the test model. So the remaining 20% of data will be applied for testing the model. Testing the model means where we are going to check the performance of that respective model. In the fifth phase, we are creating the model with the 80% of data. And in the sixth phase, we are testing the model, or we are checking
Until
the...
तभी ये वाला कर लो, document mail भी आ गई.
Hello, ma'am.
Yes, ma'am.
Okay, is there any problem?
No, ma'am.
Okay. So after sixth phase, then we are having, so after performing the fifth and the sixth phase, the last phase is where we are going to deploy that model, or what we are going to do, we are going to place that respective product into the market. So these are the most important 7 phases of the machine learning life cycle, and each and every model, it has to go through this 7 phases. Next part is types of machine learning. So there are generally 3 types, or the most important 3 types of machine learning. That is supervised, unsupervised, and reinforcement learning. So first we'll start with the first one, that is supervised learning. Now, what is supervised learning? Now, the another term that we can relate with the supervised learning is the labeled data set, or the labeled data. Means, like in general concept, the model, it has to work under an supervision. Or a simple example related to this is that students are learning under the supervision of a teacher. Whatever the teacher teaches, according to that, the student is going to gain the knowledge. Depending on the similar concept also, we are having this supervised learning, where in this particular supervised learning, the input and the output is known to the model or to the system. Okay. So similarly, now in this diagram, what we can see here, we are having some set of data, that is the labeled data. This labeled data will be passed on to the model training. Each and every object here, it is being given some name. Like for example, for the first object that we can see over here. So this object is being labeled as a square. Another object is labeled as a triangle, and the third as an hexagon. So this is what, these are the labels which are being provided to the respective objects. So these are the labeled data which will be passed on to the model training. So what the model training, so as in this particular stage, we are creating the model. So that means we are providing a training data set to that respective model. The model will get evaluated. Then with this 80% of data, now next we are going to perform the concept of prediction. So on what basis we are going to analyze that whether the model which is being generated, whether it is going to give the correct output or no. So as we are having the test data means where we are going to have apply the 20% of data. So this 20% of data will be applied to the model. Then the model is going to predict whether to which object or which object does it belong. Like for example, here we can see square is one of the object which is being given as an output depending on the label data set, and similarly for the triangle. So if the training model output and the testing data, if both are the same, that means in that case, we can say that the model has been generated successfully. So this particular same concept is being followed in the supervised learning. Now, depending on the supervised learning, we are having two concepts, that is the regression and the classification. Now, what is regression in this case? Now, regression which is going to show the relationship between the input variable and the output variable, or independent variable and target variable. Now, what is the concept of here independent and the target variable? Simple example, like when we want to perform the addition of two numbers, say like for example, A, B and C. A and B, these are the input variables. C is the output variable. So A and B, that means if 2 plus 3 is equal to 5. So like A and B, these are the values, and depending on these values, we are getting the value for the third variable, that is C. If there is again in the change in the independent variable, that is A and B, there will be change in respective in the C variable also. Means what? C will be the target variable or the dependent variable, which is giving you the output with respect to the previous variable, that is A and B. So that is why regression is nothing but which consists of continuous values and which shows the relationship between the variables. So there are n number of algorithms that comes under the regression, like for example, linear regression, polynomial regression, Bayesian linear regression. These are the algorithms. There are a set of algorithms that comes under the regression part. Second type is the classification. Now, classification is totally different. It is totally different from the regression. Classification means where we are going to create groups. Okay, and the groups will be of the similar nature. Okay, depending on the similarity, the classes or the groups will be created. Now, in classification, we are having two concepts. There one is the binary classification and second one is the multi-class classification. Binary classification means where we are going to have only two classes. That means like for example, binary means two, where like 0, 1, yes, no, true, false, positive, negative. So depending on this concept here, it is going to have only two classes. But in the multi-class classification, it is going to make use of the categorical types of data. Categorical type of data in the sense, like for example, if we are having the objects, like say we are having a basket of fruits. Okay, so in that particular baskets of fruits, there are different fruits, which may be of yellow color, red color, or green color. So depending on this, how many classes are going to be created? 3 classes. So one class will be containing all the objects of the red color. Another class, which is of green color, it is going to have all the objects of the fruits of the green color, and similarly for the yellow. So this concept follows with the multi-class classification. So depending on the attributes can be shape, color, size. Depending on these attributes, the classes are being created. Similarly, in classification also, we are having some different algorithms. Like we are having KNN, K nearest neighbor. This is also one of the algorithm that comes under the classification. Support vector machine. This is also the algorithm that comes under the second type of the supervised learning. Next part is, or the next type of the machine learning is the unsupervised learning. So as supervised learning consists of labeled data set, similarly, unsupervised learning consists of unlabeled data set. That means it does not work under any of the supervision. The machine, the model itself, it has to predict its output. As compared to the supervised learning, input and output is given to the model in the trained data set. But in the unsupervised learning, only the input is given to the model. So like for example, here you can see the images of cats and dogs. So these are just the group of images, group of objects which will be given to the respective machine. The machine is going to start interpretation. Interpretation means it is just going to start reading and analyzing each and every object. After that, it will be applied to an algorithm. Here also we are having some different set of algorithms depending on the unsupervised learning. After interpretation or reading, then it will be passed on to the processing concept. So the system, the model itself is going to analyze that depending on the, what we can say, depending on the shape of the respective object. So shape, like for example, if we are taking input over here, images of cats and dogs, so it is going to analyze the eyes, the color, the ears. All objects will be analyzed, processed, and depending on the similarity, the groups will be created. So here in this particular concept, only input is given to the model and the system is unknown with the output. So the system, it has to predict the similarities, it has to predict the output, what it has to give. So as in the supervised, we were having two types, regression and classification. Similarly, in unsupervised learning also we are having two types. One is the clustering and the association. So clustering, what do we mean by the clustering concept? Obviously, here also we are going to create some clusters or groups which are of the similar structure. But mainly in this particular concept that we are going to see here, we are going to find out the distance between the data points. If the data points are very close to each other, then that one cluster will be created. Okay. And depending on this clustering concept, also we are having some set of algorithms like k-means clustering. So what happens in the k-means clustering? We are calculating the distance between the data points, between the objects, and we are creating a group. Second one is the association. Now, association, as the name we are having, that means the objects must be associated with each other. So like for example, whenever we are buying any product, like for example, or we are going to an stores when we are buying a bread. So along with the bread, okay, there is an usual tendency that with an bread, we are going to also buy jam or butter. So means what? With the object bread, we are with the bread, there are n number of items that are being associated, or the products are likely to be bought with that respective product. That is the concept of association. And similarly, in this association concept also, there are algorithms like a prior algorithm is there, FP growth algorithm is there. So these are the two types of the unsupervised learning. Now, depending on this supervised, unsupervised, the third type that we are having here, that is reinforcement learning. Now, reinforcement learning, which is totally different from the first two types. In the first two types, in the first type, input and output is given to the system. In the second type, only input is given. But in the reinforcement learning, the model, it has to work by it itself. That is why a definition is also being given over here, that it is an intelligent agent which interacts with the environment and it is going to behave according to that particular environment. That means at the initial stage, the model is not having any of the knowledge. It has to find out its optimal solution. So the important terms that comes under reinforcement learning, that is agent, environment, state, action, and reward. So a very basic example for this is like, now as you can see here, this is an say environment or maze or a ground which is being placed over here. Now each and every block is being given some number, say S1, S2, S3. Now in this, according to the reinforcement learning, who is the agent over here? The robot is agent over here. Now this robot or this agent, it has to analyze its own step to reach to the destination. Which is the destination over here? S4 is the destination, that is the diamond. So where the robot or the agent, what it has to go, either it is going to move to S5, S1, S2, S3, and then it can reach to its destination, that is S4. That means without any obstacles, it is reaching to its destination. And when it goes without any obstacles from one place to another place or from one state to another state, means it is going to get an reward. That will be an positive reward. So if it is moving from S5, S1, so when it is moving to S5, plus 1 reward, then again plus 1 reward, plus S2, again 1 more reward. So the rewards are being getting added. But if he chooses, the agent, it chooses some different route. Like for example, from S9, it goes to S10. It will get 1 positive reward. From S10, if the agent moves to S6, X6 is the evolve. That means if the agent goes to the S6 block, it cannot move forward. It has to move backward because it cannot go to the S2 block. So when the agent goes from S10 to S6, that means invalid route it has been chosen. So it will be getting an negative reward in that case. Again, from S6, it has to move to the previous step, that is S10. Then after S10, then it can move to S11, then S12. If it goes to S8, so S8 is also an firewall. It is also an block which stops to reach to the destination, to the diamond. So in that case, again, it is going to get a negative reward. And again, it has to move backward, that is S12. So similarly, here in this case, optimal solutions it has to find to reach to its destination. So the route or the path for reaching to the destination is not common. It has to find its own way for reaching to the destination. So this concept is being followed in the reinforcement learning. Another example also we can take over here, that is the online Ludos, the game which is being played. In that case also, we have to find out, or depending on the dice, whatever the, after rolling the dice, whatever the numbers we are getting, according to that we are moving forward, or else we can come to an initial position also. Okay, so this was the example of the reinforcement learning. Now depending on the all the 3 types, okay, as the first step that we have discussed is supervised learning. So the best example for supervised learning is also can be the biometric attendance which we are using. So in that biometric attendance also, already the input and the output is given to the system. Okay, and for each day, okay, that will be the training data. And every day when we are coming, we are giving the biometric, means it is going to get matched, whether it is being matched with the input data which is being saved. If it matches, then only the attendance will be marked. So this was a basic example of the supervised learning. Similarly, for the unsupervised learning, market basket analysis, also the example. So like in this application also that we can see, that is the product recommendations. Okay, so that are all these items. Product recommendation means the products that are being associated with each other. Like for example, whenever we want to purchase Samsung mobiles, okay, so the accessories that we can purchase with that particular Samsung mobiles, it can be headphones. So that is the product which is being associated. That is the product recommendations. Similarly, if we are going to talk about speech recognition, so one of the devices that we are using, like for example, Google Assistants or Alexa, these are the examples that comes under the speech recognition. Then traffic prediction. In traffic prediction, we all are using Google Maps, or sometimes we are also sharing the location. So these are the examples that comes under the traffic prediction. And depending on this, similarly, we are having n number of applications like automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant. So there are many algorithms, many applications that comes under the machine learning. So this was all about the basics of machine learning. If anyone is having any questions, they can ask. Yes, Neeru ma'am. Neeru ma'am.